All right, I want you to grab your spiral notebook and get your graphing calculator. Okay, and what we're going to talk about in this video is solving quadratic equations graphically, which is going to be the first method that we're going to learn for solving out of 5 total methods. All right, so when you're ready, let's go ahead and get into this. What we're going to solve is negative 1/2 x squared minus x plus 3 is equal to 0. All right, well, I like that this equation is in standard form. So our overall strategy that we're going to do is we're going to enter this part right here into y1, okay? And we're going to make a parabola. And then, sorry about that. Okay, and then what we're going to do is we're going to put this part right here, we're going to enter the 0 into y2. And what we're going to see is a horizontal line at 0. And the overall goal is to find the intersection of y1 and y2. That's pretty much how you can solve any equation graphically, is put the left side in y1, put the left side in y2, and find the intersection. All right, so let's go into our calculator and let's go ahead and enter that in. Now, for y1, we're going to type in negative 1/2 x squared minus x plus 3. Okay, a couple troubleshooting things before we get started to avoid getting any kind of a graphing error. First thing, look up top at the plot 1, plot 2, plot 3. If any of these plots are highlighted the way my plot 1 is, I want you to go up, I want you to hit enter, and I want you to unhighlight those, okay, because a lot of times having a plot turned on, which is what it means when it's darkened in like it was, means it oftentimes gives you an error when you go to graph. The second thing I want you to do is instead of hitting graph, because your window might be a little bit messed up, if you hit zoom 6, that will take you to a standard 10 by 10 viewing window. So it kind of puts us all on the same page. All right, so here's the parabola, okay, and that's y1, and coming across in y2 is going to be this horizontal line, y equal, oh, you know what? That's a good thing. I forgot to put that in. So let's go down into y2. And let's put in y equals 0, which I'm kind of glad I did that because often, especially with the black and white calculators, you can't see that line, all right? It just looks like the x-axis. So with the color calculators, you can visually see that you have 2 equations in, but with the black and white, sometimes I forget to put the 0 in and I can't tell because I can't see it. So just make sure you have something in y1 and y2. So what we're going to do is we're going to find the intersection now. Where are the intersection right here is the roots of the equation because that is where it crosses the line y equals 0, which is the x-axis. So we're going to hit second trace, we're going to go to intersect, and we're going to find those intersections. Now I'm going to start over here with this root that's over on the right because it's a little bit closer. And when you move your cursor over the intersection, we're going to pretty much hit enter for the first curve, enter for the second curve, enter to take a guess. Okay? And we're going to write our answer as 1.645. I don't really care if you want to round the 5 up, just round the 5 up, or if you want to truncate and just write the first 3 decimals you see. But it's important to note, we do not round this to the nearest whole number. We leave it as 1.645. This is an approximate solution. So let's go ahead and let's do second trace again, and let's find that other intersection. Now, my calculator is painfully slow, so I'm going to cheat a little bit and get there a little bit quicker. Okay, second trace, go to intersect, and then move your cursor over to that other intersection, and when you're ready, we're going to hit enter, 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 and here comes the second solution, negative 3.645. Okay, and those are the 2 solutions to this equation. So we would say x is equal to negative 3.645. Again, you can either round the 5 up because of the next digit, or you can truncate and just give the first 3 decimals. Both are acceptable means for rounding. All right, and 645, and those are the solutions that we just found graphically. All right, let's take a look at another scenario here. Example 2. Let's see here. X squared equals 12 times x minus 3. All right, well, the first thing is I like to first work with this a little bit and get the equation in standard form. So let's go ahead and distribute the 12 over here on the right, and we're going to get 12x minus 36. Now, I know that it seems easier to minus over the x squared, but to build to build habits for what's coming in this unit, I suggest you leave the x squared where it's at, and instead I'm going to minus the 12x over, and I'm going to add the 36 over. I just don't love solving equations with a negative leading coefficient, so if I can avoid it, I'd rather leave the x squared positive and get all the other terms on the same side, okay? If you minus over the x squared, then you're going to end up having to factor out a negative, and it just makes more work. So again, this is going to be y1, the 0 is going to be y2, and we're going to figure out where the two intersect. So let's go into our equation and let's write a new y1. And what is this? X squared minus 12x plus 36. And we got y2 is 0. Hit graph when you're ready. And so here comes the parabola. And this time it's interesting. It appears that it is touching the x-axis at one place. Okay? So let's go over there and let's take a look at what's going on. Let's go to second trace and let's hit intersect. Now, this is another thing that happens, and I'm glad this is happening so we can talk about it. Sometimes you can't see your cursor, right? You just keep feeling like you're pressing arrows and you can't find it. That's when I want you to look right here at the y value. See, it's up at 24. So we just need to keep hitting the down key. So if you can't ever find your cursor, you just need to look at these y values right here. And once they start being less than 10, our cursor will pop up in the window. And there it is. Okay? So keep your cursor going down and go over that intersection. And we're going to repeat those steps. And my calculator is painfully slow right here. And when you're ready, you're going to hit second trace, and we'll hit enter, enter, enter. Okay? Second trace, intersect, enter, enter, enter. And in this case, we see that the solution is 5.9999976. Now, this is another interesting thing we need to talk about. Your calculator is using an approximation technique. Okay? So the answer is actually x equals 6. So when you have answers like 5.99999, or you might see 6.00001, you are allowed in that case to round it to the whole number. Okay, but notice we didn't round the last example to a whole number, but you are in this case. So that's another little disadvantage with the calculator, is sometimes you get an approximate answer when really it is x equals 6. And so what we can see here sometimes is that we could have a solution, and we could have two solutions, but you can also have one solution if the vertex is on the x-axis. All right, example 3. All right, let's solve, okay, negative 2x times x minus 6 is equal to 19. Again, just a little bit of work. Let's get this in standard form. I'm going to distribute the negative 2x. We get negative 2x squared plus 12x equals 19. And then let's go ahead and just minus over the 19. Okay? And let's go from here. All right? I think you kind of get the idea now. This is going to be y1. This is going to be y2. And let's take a look at what we have going on. So y1, clear out, is negative 2x squared plus 12x plus minus 19. Okay, and we still got our y2 is equal to 0. And so in this case, we look at the parabola, and it's interesting because it doesn't cross the x-axis, right? So we don't have an intersection to find. While it's tempting to say no solution, I need to add something to that. There are solutions, okay? They're just not real solutions. And so the real solutions are where the parabola crosses the x-axis. There's other types of solutions that we're going to learn about in this unit, okay? And that is another disadvantage of the graphing calculator, is if the parabola doesn't cross the x-axis, we can't then give the solutions or the roots. So in this case, what we're going to say, okay, is we're going to call this no real solutions. And we will certainly learn later on what those other types of solutions are, but for now, we just say no real solutions. And that is another reason why we need more graphing methods, because the calculator has limitations. So the last thing that I want to do, okay, is just kind of touch upon, again, that idea of the disadvantages of a calculator. So I'm just going to type this in. You can certainly type this in with me if you want. You can just kind of watch but I do want to make this point before we end the video. X squared minus 2.8x plus 1.92. So sometimes what happens, all right, you can, like I said, if you want to type it in with me, go ahead. But when I hit graph, okay, I look at this parabola and it appears, yep, it appears that it looks like we have one solution, okay? Now, when you go to zoom in, all right, and so what I'm going to do, and again, all I did is I just went to zoom. I went to zoom and I went to number 2, which was zoom in, if you're doing this with me, but I'm good too if you just want to watch. And I want you to move your cursor over to where it looks like that vertex is. And when you're ready, I want you to hit enter. And what's going to happen is it's going to kind of like enlarge the picture right at that point where you hit enter. Okay, and so when I do that, and we kind of look a little bit closer, what I can actually see is that this parabola, yep, do you see right there? It actually goes below the x-axis and comes back up. And so that's where it can be a little bit tricky, is in sometimes, maybe if we zoom in, I don't know what's going to happen, but maybe if we zoom in again, we can even see a little bit better. But that's what we have to be careful about, is there's times where you might actually have 2 roots, but when you're in a standard 6 by 10 by 10 window, it appears that there's only one. So again, limitations of graphing. And then finally, the last limitation of graph, well, it's not really a limitation, it's just something I want you to be aware of. And I'm just going to type in an equation real quick, right? 1/2 x squared minus 8x plus 24. Okay, you can just watch on this. It's just a little point I'm trying to make. So the other thing that can sometimes happen is we go to graph the roots, and maybe one of the roots is way out of the viewing window. Okay, and that's the other thing that happens, is sometimes it's a little annoying having to adjust the window to see both of the roots. Well, what I would do is I would go over and I want my x max, instead of ending at 10, I'm going to make the x max go to 20 in the window. And so then when I graph it, it'll take my graph a little bit further out on the x-axis, and then I could go ahead and I could find the 2 roots. Okay, so those are just things that we need to be aware of, is adjusting the window when we need, or being careful that we don't make assumptions when maybe we're not getting the full picture of what's going on with the equation. So that is it for now, and thank you for tuning in, and we'll see you next time.